Now this lesson is on solving simple linear equation. The essential question here is how can you use simple equations to solve real-life problems? So what we're looking here is at some vocabulary maybe you're not familiar with, or maybe you've forgotten what they mean. An equation is a statement that two expressions are equal. It's got that equal sign in there. A linear equation is one variable is an equation that could be written in the form of ax plus b equals 0, where a and b are numbers. And a solution of an equation is a value that makes the equation true. Inverse operations are two operations that undo each other, such as addition, subtraction, multiply, divide. And equivalent equations are equations that have the same solution. So our core concept here is we're going to be looking first at the addition property of equality, which just means that adding the same number on each side of an equation produces an equivalent equation. And the subtraction property of equality is just that if we're subtracting the same number from each side of an equation, it produces an equivalent equation. So we can come over here and try an example here. I believe many of you have tried this where you've done the line going down through the equation, the equal sign, so you make sure you do whatever you do to the left side, you do to the right side. So that's what we're going to do here. Now, according to the addition property, we can do the inverse operation to get rid of it. We're subtracting, so we're going to add. So all you're going to do here is add 3 to both sides. By adding 3 to both sides, that cancels this out, and we're left with just x over here. And on this side, we have negative 2. So we have x is equal to negative 2. Now, this is according to the addition property. Now, if we move on here, we can try and check it. It's always good to check it to make sure. All you got to do is put that negative 2 in. So we've got negative 2 minus 3 equals negative 5. That's a question. Are they equal? Well, negative 2 minus 3 is negative 5, so our check is good. So let's look at this example. Again, we'll draw our line going down, but this time the variable's on the right side. And remember, our goal here is to isolate the variable, get the variable by itself. So what we need to do here is, according to the subtraction property, we can subtract 2.8 to both sides, and it's going to be the same equation, but that gets our variable isolated, because those will cancel out, and we're left with a y over here, equal to 0.9 minus 2.8, which is negative 1.9. And again, you're going to want to check this. So you put in negative 1.9. Well, negative 1.9 plus 2.8 equals 0.9, so check. That one's correct. So let's look at the next core concept here. We're looking at the multiplication property of equality. That's the same thing. Multiplying each side of an equation by the same non-zero number produces an equivalent equation. Same for the division. Dividing each side of an equation by the same non-zero number produces an equivalent equation. So when we're looking here, we'll draw our line down again. And remember, whenever it's set up like a fraction, remember fraction is division. So we got to do the inverse operation. The inverse of dividing is multiplying. So we're going to be doing the multiplying property here. So we're going to multiply this. Now be careful of this negative. We're going to go ahead and put the negative with the number. That way we can get the variable completely by itself. So we're going to multiply by negative 5 to get rid of it. And whatever you do to one side, remember to do to the other. So we're going to multiply by negative 5 on both sides, and that's going to get our n by itself. And then remember, a negative times a negative is going to be a positive. So we've got n equal to 15. You can go ahead and plug it in and see, and have 15 divided by negative 5 is going to give you a negative 3. So that one checks out also. So let's try another example. This one's got pi in it. A little different here, but you're going to be doing the same kind of thing. It's according to the division property, because remember, when there's no sign in between, you're doing multiplication. So here the number is pi, so we're just going to be dividing by pi to isolate that variable. These pi's cross out, and these pi's cross out. So you've just got x is equal to -2. You can go ahead and put that in your calculator and give that one a try to double check it. But for the C one, again, doing our division property because we have multiplication going on, we want to take the 1.3z and divide by 1.3. And if you put that in your calculator, you're going to get that z is equal to 4. And again, you can put that in and double check it. 1.3 times 4 is going to give you 5.2. Now, how are we going to use this information in real life? Well, there's a 4-step approach to problem solving. First, you need to understand the problem. What is the unknown? What information is being given? What is being asked? That you got to figure out. Now make a plan. This plan might involve one or more of the problem-solving strategies that we'll show a little bit later here. And then you want to solve the problem. Carry out your plan. Check that each step is correct. Then, your most important thing is to look back. Examine your solution. Check that your solution makes sense in the original statement of the problem. I mean, you don't want to end up with like a negative number for something that you know you can't have -6 hot dogs or something. So let's look at this example. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So first you need to understand the problem. You know the winning time and the distance of the race. You are asked to find the average speed to the nearest hundredth of a meter per second. So then you've got to make a plan. We're going to use the distance formula to write an equation that represents the problem. And then we're going to solve it. Well, we remember that the distance formula is distance equals rate times time. Well, we know the distance is 200. We know time is 19.32. So now we just got to find the rate. And to find the rate, we got to isolate the variable, the r, so we need to divide each side by 19.32. So when we do that, we get approximately 10.35. So Bolt's average speed was about 10.35 meters per second. So let's look back though. Round Bolt's average speed to 10 meters per second. At this speed, it would take him 20 seconds to run 200 meters. Because 20 is close to the 19.32, your solution is pretty reasonable. So looking at some of those common problem-solving strategies, you can use verbal model, you can draw a diagram, write an equation, look for a pattern, work backwards, guess, check, and revise, sketch a graph or number line, make a table, make a list, or break the problem into parts. So if we're looking at another example here, on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees at 9:27 a.m. How many degrees did the temperature fall? Now make sure, because there's a lot of numbers in there, but they kind of throw in some extra information that you don't necessarily need. But you need to do step 1, understand the problem. You know the temperature before and after the temperature fell. You are asked to find how many degrees the temperature fell. So let's make a plan. Use a verbal model to write an equation that represents the problem, then solve the equation. Well, we know in words the temperature at 9:27 a.m. is equal to the temperature at 9 a.m. minus the number of degrees the temperature fell. So we're just going to go ahead and let T be the number of degrees the temperature fell. So we've got -4 equal to 54 minus T. So again, according to the subtraction property, I can subtract 54 from each side to isolate that variable, and we've got -58 equal to -T. But wait a minute, the variable is still not isolated. We've got a negative sign in front of that. So to take care of that, we can divide each side by -1. Because remember, any number that you divide by a negative, you equal a positive. So if we divide by -1, we're going to get that the temperature was 58 degrees. So the temperature fell 58 degrees. So now you can look back. the temperature fell from 54 above zero to 4 degrees below zero. And you can use a number line to check your solution and see if it is reasonable. So go ahead, and you have an assignment on Clever, but make sure you show me your notes so you get credit for those too.